Exploring building blocks. So let's watch what happens when we spray paint a cube. So we spray painted one face, so it's a 1 by 1 array or area of a face painted. How many faces will be painted by a 2 by 2 array? So notice this is a 2 by 2 block, so there are 4 faces that are painted. And right here is a 3 by 3 array, so there are 9 faces painted. All right, let's get ready to fill out our table. So as you see here, we just talked about a 1 by 1 array has 1 face. A 2 by 2 array has 4 painted faces. I can write that down as 2 times 2 equals 4. A 3 by 3 array has 9 painted faces. I can write that down as 3 times 3 equals 9, which means the number of faces painted is 9. Let's move on to the next slide. So let's move on. We already did the first 3. What if the height of the cube is 4? Then a 4 by 4 array has 16 painted faces. I can write that down as 4 times 4 equals 16. Or since there are 2 4s, I can write that down as 4 squared equals 16. Either way, the number of faces painted is 16. If the height of the cube is 5, a 5 by 5 array has 25 painted faces. I can write that down as 5 times 5 equals 25. Or since there are 2 5s, 5 to the second power equals 25. So the number of faces painted is 25. So now let's make it a general statement. So an n by n array, so that means any size has an n squared faces to paint. Therefore, the function rule is f, the function, equals n squared. Slide 5. So as we notice down here, an n by n array has n times n painted faces. Please fill that out in your table. So the process is n times n equals n to the second power, or n squared, because there are 2 n's we're multiplying. So the number of faces painted is f, the function, equals n squared. Is this pattern linear? No. There is no constant addition pattern here, which means it is not linear. All right, so domain is x, so right here are all the domain numbers. Range is y, so all right here are the range numbers. So the domain values, which is the heights, must be positive integers. The range values are the number of faces painted, consist of square numbers such as 1, 4, 9, and 16. Let's skip the practice for now and go to slide 7. So what does x represent? X represents always the first in the table, which is height in cubes. Y always represents the second in the table, which is number of faces painted. So this is what the scatter plot looks like in your calculator. And this is what it looks like when I type in y equals x squared, so an equation, over the scatter plot. Notice that the line goes through those points. So now graph the function rule y equals x squared. How does a scatter plot and graph compare? The graph of the function rules contains more points than the scatter plot. A graph with this shape is called a parabola. The data relationship or function that creates a parabola is called a quadratic function. The point -2, 4 lies on the graph of the function rule, but does not apply to the problem situation. Why? So right here we're talking about the height of square area and the number of faces painted. So even though -2, 4 lies on the graph of the function rule, you cannot build a square area with a height of -2. The data on the graph of the function rule, y equals x squared, is our continuous data. The scatter plot of a graph is discrete.